This video is going to go through coordinate systems and vector components. So this is now when we are getting to working with vectors in a quantitative way. Now, some earlier videos have talked a little bit about some of the notation that we'll be talking about and how to define coordinate systems, but we'll be reviewing that. And we will be doing some of the math of creating vector components. Now, one thing, there will be a second video that goes a little bit more into the vector math in particular, and there's a separate video that reviews some of the trig basics. So this video won't contain everything with regards to those two topics. The two big learning outcomes this connects to is representing. In particular, whenever you're drawing vectors, you're sometimes going to be drawing vectors based on a written description. So it's really important that you understand the conventions of how we draw vectors and how we are relating quantitative, written, and visual representations of vectors. In terms of problem solving, for a significant portion of this class, we will be working with vector math, especially in terms of forces, so you need to be able to quantitatively manipulate vectors, not just add and subtract them graphically, but do so numerically, and this video is a big stepping stone to get there. So first I want to talk a little bit about coordinate systems. Now this is a very basic picture, so hopefully you know that the horizontal one we typically call x, and going to the right is in the positive direction. Up and down we call y, and we call that the positive direction when it's up. Now again, if you define your coordinate system differently, it's going to make it harder for other people to follow your work. And when you draw these by hand, you don't necessarily need to draw all four coordinates. So for instance, if I just draw this, then you really only have this first coordinate, but that's enough to say that you're going to be working with positive values of x and positive values of y. Now, one important thing that is noted here in the figure is that these two things are at 90 degrees to one another. And whenever we're working with coordinates, and I will introduce some other coordinates that we might use in addition to x, y, and z, what's important is that they are 90 degrees with respect to one another. So if you want to define a different coordinate system, that's okay, as long as they're all perpendicular. Now another thing that we might do is have a third direction. Now this gets a little bit tricky to draw since I'm drawing on a two-dimensional surface, but one way to draw this is to again draw our x and our y, and then have z, and this means coming out of the page. So this is in fact a 90-degree angle, and this is a 90-degree angle, but that's an attempt at a three-dimensional drawing. Now, not very good, and if you wanted to draw something on there, that would be pretty hard to work with. Another way of doing an xyz coordinate system is again x, y, and then we say that z is this dot, which is out of the page. So, or in this case, board, computer screen, whatever. And so we can use x's to represent into, like you're looking at the tail of an arrow, and these dots, usually within a circle, to represent out of. So we won't normally be working with three-dimensional coordinate systems in this class, but in the second semester of physics, three-dimensional coordinate systems come up a lot. So I wanted to cover that right now. With coordinate systems, we get unit vectors. This is one of the few places where I use a different notation from the book. So the book is using this I hat and j hat. And note that whenever we say, for instance, have I hat, that little up arrow, it isn't really an arrow, it's a hat, and that means unit vector. What I will typically do, instead of I hat and j hat, is use x hat and y hat. Using I hat and j hat, this is not wrong. If you are used to doing this, that is fine. However, I've always felt like it's a little more intuitive to call the unit vector in the x direction x hat, and the unit vector in the y direction y hat. That makes more sense to me. And if this is your first time working with unit vectors, this might make more sense to you as well. So if you've already learned I hat and j hat and you're comfortable with that, feel free to use that. That isn't wrong, and that's what the book will do. However, I'm typically going to use x hat and y hat since I think that's a little more clear. So unit vectors are going to have a length of 1. And one thing to be careful about is that there aren't actually units on this. So this is showing it with a length of 1, but if this was x measured in centimeters, you wouldn't necessarily say that I has a length of 1 centimeter. It just has a length really of 1. And we're going to say that they're perpendicular. So note that these are perpendicular to one another. And really what that comes from is, again, each of these corresponds to a coordinate, an axis direction, and those must be perpendicular to one another. So we will work with some other unit vectors, but we're always going to be working with sets of unit vectors, and that set is going to be perpendicular to one another. Another thing that I'll mention here is if you wanted to add that third direction, that would be z, and in the ij, that is unsurprisingly k hat. So if you, for whatever reason, need to work with 3 dimensions, that's your set of unit vectors in 3 dimensions. So I'm going to cover something that I think makes sense to cover right now, but actually comes a little bit later in chapter 3, and that's the idea of a tilted coordinate system. This is another place where I make a slightly different choice than the book, and it isn't that the book and I disagree as much as I do this consistently and the book sometimes does it a little bit differently. So here, the book has shown x and y just tilted, and there's nothing wrong with this. This absolutely is fine to just pick your x direction off at an angle and your y direction off at an angle. Now, I think that that's a little bit confusing since normally we take x to be horizontal and y to be vertical. So what I would encourage you to do if you're going to generate a tilted coordinate system is to label it differently and call, for instance, this, what the book called x, call this your parallel direction, and call the other one your perpendicular direction. So we then have a unit vector this way, that is parallel hat, and a unit vector this way, that is perpendicular hat. And the reason I call it that is because you get into these situations, for instance, if you have some sort of slope that maybe you have a skier on. There's no way this drawing will come out good. Okay, so we have a skier on our slope. And let's say we want to think about forces and accelerations or something like that. So you know that there is an acceleration due to gravity. And here's why I like labeling the tilted coordinate system differently, is that we always write this as negative g in the y hat direction. If you have tilted your y direction, this is no longer true. But in this case, you can see, if I've called this parallel and perpendicular, that I have to break my acceleration into parallel and perpendicular components. It is not in either of my axis directions. So this is why I would encourage you, whenever you work with a tilted coordinate system, to actually call that parallel and perpendicular, because you might still be used to thinking about certain accelerations or forces in x and y, and if you think of y as being up and down, that's not what you have here. The other reason is that we're going to eventually work in some scenarios, especially in forces, where you have some forces that are perfectly horizontal, some that are perfectly vertical, and we might refer to those as x and y, but then you have other forces that are parallel and perpendicular to a surface. So there are some scenarios where you might actually do part of the problem in x and part, well, xy, and part of the problem in parallel and perpendicular. And if you have 2 coordinate systems, one which is tilted and one which is not, you must call them different things. So again, if you clearly draw your coordinate system and call it x, y, and it's tilted, I'm going to be able to follow your work as long as you do your work clearly. But for your own sake of not making mistakes, like in this case thinking g is along your y-axis, I would encourage you to use the parallel and perpendicular notation instead.